Ever wondered how engineers manage to construct the underwater foundations and supporting structures of massive bridges? It's a question that delves into the heart of engineering ingenuity. Building these submerged elements is one of engineering's greatest and most complex challenges, pushing the boundaries of what's possible. You simply can't just drop concrete directly into the water and hope for the best outcome. That approach would be a recipe for disaster, leading to structural instability. The foundation must be exceptionally strong and durable to reliably support thousands of tons of weight, including the bridge itself, vehicles, and even environmental loads like wind and seismic activity. First, engineers conduct thorough surveys of the riverbed or seabed, using advanced sonar technology to map the terrain and core samples to analyze the soil composition. This detailed analysis helps them decide on the optimal location and design for the bridge's piers, ensuring stability and longevity. The ultimate goal is to create a solid and unyielding base, situated deep below the water's surface, sometimes extending hundreds of feet down to reach bedrock or a stable soil layer. So, what's the real trick to all of this? It's all about creating a dry, safe, and stable workspace in the challenging underwater environment. This often involves strategically pushing water away from the construction site, carefully digging through layers of mud and sediment, and precisely pouring concrete to form the foundation, all while the entire operation is submerged beneath the water's surface. The main methods employed for this undertaking include the use of cofferdams, the implementation of caissons, and the utilization of floating platforms. Each of these methods is carefully chosen based on the specific water depth at the site and the prevailing environmental conditions. These aren't just standard construction techniques, they're remarkable feats of engineering problem-solving, requiring innovative approaches and meticulous execution. They ultimately allow us to build in locations where construction might otherwise seem utterly impossible. So, let's dive in and take a closer look to see exactly how these incredible underwater giants are meticulously designed and brought to life. When constructing bridge foundations or other underwater structures, one of the primary challenges is creating a dry workspace. The simplest and often most effective solution is the cofferdam, a temporary watertight enclosure designed to keep the water out and allow construction to proceed in a dry environment. It's essentially a temporary dam, built right in the river or body of water where the foundation needs to be placed. Huge steel sheets, often corrugated for added strength, are driven deep into the riverbed, forming a continuous barrier against the surrounding water. This process requires specialized pile driving equipment to ensure the sheets are properly interlocked and create a secure seal. These sheets are arranged to form a box or sometimes a circular shape depending on the specific requirements of the project. Once the steel sheet enclosure is complete, powerful pumps are used to continuously remove the water, evacuating the area within the cofferdam. This process gradually reveals a dry, often muddy pit, where the construction work can then proceed. The result is a contained construction zone, completely surrounded by water, but dry inside. Workers then excavate down to solid ground, preparing the base for the foundation. Once the excavation is complete, they pour concrete and add steel reinforcement to form the robust and durable foundation required for the bridge or structure. Cofferdams work best in relatively shallow water conditions, typically up to about 75 feet deep, depending on the design and engineering. They're relatively quick and cost-effective compared to other underwater construction methods, making them a popular choice for smaller rivers or lakes. However, in deeper water environments, the immense water pressure becomes too great for cofferdams to withstand effectively, and rocky riverbeds can make creating a watertight seal virtually impossible, leading to potential failures. In these challenging scenarios, that's when experienced construction engineers must turn to the next big solution in underwater construction technology: the caisson. When cofferdams just won't cut it, when the soil is too unstable or the water too deep for a simple enclosure, engineers need a more robust solution. Cofferdams, while effective in many situations, have their limitations, especially when faced with challenging underwater conditions. That's when engineers turn to caissons, a truly impressive feat of engineering. These massive structures provide a stable and reliable foundation, even in the most demanding environments. Caissons are essentially giant, hollow concrete boxes, meticulously designed and constructed to withstand immense pressure and provide a solid base for bridge piers. Their sheer size and strength are a testament to human ingenuity. And the best part? These aren't just temporary structures. They become an integral part of the bridge, a permanent foundation that ensures its long-term stability and safety. The process begins with open caissons being carefully floated into their precise position, a delicate operation that requires expert navigation and precise control. Imagine maneuvering these colossal structures across the water. Once in place, the real work begins. Workers dig inside the caisson, carefully excavating material as the structure slowly sinks, inch by inch, deeper into the riverbed. This controlled descent allows the box to settle deeper and deeper, gradually finding its footing in the underwater terrain. It's a slow and steady process, but crucial for ensuring a solid foundation. The ultimate goal is for the caisson to reach solid ground, ideally bedrock, providing an unyielding base for the bridge above. This connection to bedrock is what gives the caisson its exceptional strength. With the caisson firmly in place, the chamber is then meticulously filled with concrete, creating a solid, monolithic structure that can withstand tremendous weight and pressure. The result is a rock-solid pier, an unwavering support that forms the backbone of the entire bridge. It's a testament to the power of concrete and the precision of engineering. But what happens when the underwater conditions are particularly challenging, with especially wet or silty soil that makes excavation difficult? In these situations, pneumatic caissons come into play. These specialized caissons utilize compressed air, creating a unique and effective solution. The compressed air acts as a barrier, working to keep water out of the work area and allowing for dry excavation. This ingenious design lets construction crews work comfortably and efficiently in a dry, pressurized space even deep beneath the water's surface. It's important to acknowledge that this method was historically quite risky, with workers facing potential health hazards due to the pressurized environment. However, advancements in technology, including the use of robotics and remote-controlled tools, have significantly improved safety. These innovations have made the process far safer for the workers involved, minimizing the risks associated with pressurized environments. Ultimately, caissons serve as the unwavering anchors for bridges, providing the essential support needed to span vast bodies of water. They are particularly crucial in deep and challenging waters where other foundation methods simply wouldn't be feasible. Caissons make the seemingly impossible possible, enabling the construction of vital transportation links across formidable waterways. They are the go-to solution where nothing else works, a testament to the ingenuity and determination of engineers to overcome even the most extreme construction challenges. For deep seas or fjords, even caissons aren't enough. Here, engineers build bridge sections on land, then float them out on barges. Massive cranes lift these segments into place piece by piece like a giant Lego set. Precision is key. GPS and lasers guide every move, and weather can halt work for days. Divers and remotely operated vehicles inspect and guide underwater assembly. Innovations like self-climbing formwork and epoxy-coated steel help towers rise and last longer. These floating giants connect places once thought unreachable. Finished bridges hide the epic struggle beneath the surface, cofferdams, caissons, and teams battling the elements. These structures are more than concrete and steel. They're symbols of human ingenuity and connection. Bridges transform lives/travel times and unite communities. Icons like the Golden Gate and Akashi Kaikyo Bridge inspire awe and pride. New materials and smart sensors are making bridges safer and longer lasting. Next time you cross a bridge, remember the hidden world below and the people who built it. Bridges prove that no obstacle is too great for human creativity. They connect not just land but people, and that's truly brilliant.